Hi everyone. Okay, so in this session we will continue our lecture on the ILD. So basically in the previous part we have learned how to develop the ILD diagram for the directions, shear force and the bending moment. So for this session we will also learn how to use that particular ILD diagram in order to find out the maximum value of shear force, bending moment and direction at a certain point in the beam. Okay, so without further ado, let's be discuss in detail on this. Uh, by using the example 7, we will demonstrate how we can use the ILD to determine the maximum and positive shear at point C and also the maximum positive moment at C. Okay, so what you can see in this diagram is overhanging beam. So basically, we have determined the ILD diagram. We have developed the ILD diagram for shear and the moment at the point C in example 3. So we can recall that examples and you can see that in these examples it shows again the step that we have discussed in detail before. Okay, so this is the support reactions and this is the diagram that we have seen before. And I don't want to discuss in detail on this because we have done it before. So I would like to focus on how we can apply the ILD diagram for shear and for the moment in order to find out this particular value, maximum positive value of shear and moment at the point C. Okay, let's take a look on the ILD for shear force. Okay, so this is a ILD for shear force diagram. Okay, so to determine the maximum positive value of a shear force in the diagram, you need to move this particular load, which is 8 kilonewton point load, along the diagram. Okay, so you need to place this particular point load at a position where it will give a critical value or the maximum value. So what you can see in that diagram, so we have a positive side and negative side. The positive side is above the x-axis, the negative side is below the x-axis. Okay, so since the question asking about the positive, the maximum positive value of a shear force, so you need to look at the above side of an x-axis. So meaning that you need to place this particular point load along the diagram and ensure that the position of this particular point load must result the maximum value of shear force on a point C. Okay, so based on this diagram, you can see that the highest value on the positive side is 0.5. So they have two points. They have two places here. At this point and at this point, which is 6 meter from support A. The free end, if I'm not mistaken, is okay. This is a free end. Okay, so this free end is a support B. Okay, so this is a free end. This is support B. So meaning that based on the ILD that we have developed, we have considered that the X is moved from this point towards the point B. Okay, so this from this free end to the point B. Okay, so by positioning the point load, okay, you can positioning at this point or at this point. So this will give the same value of a shear force, maximum positive shear force. Okay, so and you can obtain the maximum value of a shear force by multiplying the value of 8 kilonewton with respect to the maximum factor, which is in this diagram is the maximum factor that we have identified is 0.5. Okay, so and this gives the value of shear force equal to 4 kilonewton. So the maximum positive shear for the case at point C is equal to 4 kilonewton when this particular point load is positioned at a pre-end and another point is 6 meter from the pre-end. Okay, so they have two positions that will give this maximum positive value. Okay, so let's move on the ILD for a moment. Okay, so in this diagram you can see that the this is a shape of ILD that we have developed in the previous part. Okay, so and again in these problems we want to get the value of a maximum bending moment value. So in other words, you need to move this particular point load along the diagram and find out the most critical value that can produce the positive moment. So in this diagram, you can see that this is a positive side, this is negative side. So you need to focus on the positive side. And obviously, you can see that the maximum, the peak point here is located here, which is a 4 meter from the free end. So for sure, you need to put this particular 8 kilonewton point load at this particular point. And by multiplying this 8 kilonewton load with respect to the factor, which is by offset this point towards the vertical axis, so it gives us the want value. And multiply this once with 8 kilonewtons, so you can see that the value of maximum positive shear at the point C is equal to 8 kilonewton meter. So meaning that this value can be obtained. Okay, so this value of maximum positive shear will develop when the bike is positioned 6 meter from the free end. Okay, so let's look on another example. Okay, so in example 7 we have seen on a 1 point load. In this example we have a 2 point load, which is demonstrated by the vehicle load or the truck here. Okay, so the wheel load of a truck will impose a point load of a 5 kilonewton for the front and the rear wheel. Okay, so in this problem, we will find out the maximum positive shear at point C and the maximum positive moment at the point C. So, and again, basically, this particular problem has been seen, if I'm not mistaken, in example 2. Okay, so we have developed the shear and the moment ILD for this problem in the previous example 2. Okay, so this is what we have seen before. So, and this is equation of moment, and this is a diagram of shear force, and this is a diagram for the moment. So in the example, we will focus on how we can apply the vehicle loads to get the maximum positive value of shear and the moment. Okay, so let's look on the shear diagram. Okay, so based on this diagram, so I have explained in the example 7, so you need to look on the positive or negative side. So since in the problem we need to find out the maximum shear, the maximum positive shear value, so you need to look on the upper side of this x axis. Okay, so and obvious you can see that this is a peak point. So you need to move this particular vehicle load along the diagram, and ensure that this particular load must give the maximum value of shear force when it's multiplied with the vertical factor here. Okay, so and so obviously you can see that this position will give the maximum value of positive shear. Okay, at the point C. Okay, so since we have two wheel, so so this vehicle is moved from A to B. Okay, so meaning that this is a rear wheel, this is a front wheel. So the rear wheel must be multiplied with 0.6. The front wheel must be multiplied with the 0.4. Okay, so by looking on this, you can see that the BC is equal to 5 kilonewton. Okay, so this is a position of a vehicle where you can see that the positions is the rear wheel is located 4 meter from a support E. Okay, so this position will give the maximum value of shear force at point C. Okay, and if you move this particular shear vehicle load along the diagram, so you'll get the corresponding value of the shear force. Okay, so by using the usual beam analysis, actually you need to repeat the procedure many times. So if you move this particular vehicle at a different position along the beam. Okay, so you can see that how powerful this particular ILD approach to determine the critical value in a beam. Okay, so and I have mentioned that this method is very useful to analyze the bridge structures. Okay, so let's discuss on another example, which is example 9. So this time being we have 3 numbers of wheels on a beam that's generated by this particular vehicle. Okay, so in these problems we deal with the simplest of the beam. So the diagram will be the same because to develop the ILD you need to apply 1 unit load. Okay, so you can see that the diagram remain the same as what you can see in example 8, but here we want to get the value of maximum positive shear and moment at point C based on this load arrangement. Okay, let's look on the first part, which is on the positive shear at C. Okay, so basically you need to position this particular load along the diagram, okay, in order to get the maximum value of the shear force. So straightforward, this is a position of a vehicle that will produce the maximum value of a shear force at C. Okay, so this is a positive side, this is negative side. So you need to be careful on this. If the question asking about the negative value of shear force, maximum negative value of a shear force, you need to ensure that this load of vehicle must be give the maximum value of a shear force. In other words, you need to look on the diagram below the x-axis. But these examples, we want to get a positive value of a maximum shear force. So these arrangements will give the maximum value which is equal to 13 kN by looking on this equation, where the, every wheel load must be multiplied with the corresponding value of factor in a vertical axis. Okay, so I hope you can figure out yourself how this value of a wheel multiplied with the vertical axis. Okay, so for the bending moment, okay, so this is a ILD for the bending moment that we have established in the previous example. So as this is a position where you can get the value of maximum shear force, maximum bending moment at a point C. Okay, so and since we have 3 wheels, so you need to find out the value of factor for the corresponding wheel. For instance, here you can see that 10 multiplied by 2.4, which is this 2.4 is come from the vertical axis of this diagram. So for the 5 and 15, the factor is 2 and 1.2 respectively. Okay, so by total up of this value, you can see that the maximum value of moments at point C is equal to 50 kN. Okay, so this value of maximum moment has been generated based on this position, where you can see that okay, so this is a front wheel, this is a rear wheel, so this is an intermediate wheel. So the vehicle is moved from B to A, so meaning that this is the rear wheel, this is a front wheel, this is an intermediate wheel. So the vehicle moved from this point towards this position. Okay, so that's it for today. So thank you for listening. So see you again.